All right, so well, we saw arrays in the last class, right? So today we're gonna continue seeing arrays because we have to finish this particular topic. Well, I asked, how are you? And nobody answered. It seems that, can you hear me, guys?
Yes. Hello,
Everything's,
everybody.
everything's okay? Okay, so let's continue with arrays, and I'm gonna use here the same package that I used before, right? And now I'm gonna create one class here, and I'm going to call it uh, using wrappers in list. Using wrappers in list, right? So remember the wrapper class is the one that has the integer in capital letter, float in capital letter, double in capital letter. Okay? Those are the wrapper classes. Okay, so I'm going to create this guy here. Okay, so I'm going to say list. Remember that's an interface, and then there's the wrapper class double, right? And of course, it will immediately, import the interface. Okay, so I'm going to say double list, call it double list equals new array, like we did before, and then I have this here. All right, so we have now a list of doubles, right, with the name of double list. Okay, now I can say double list add, because that's the method that a list has, 10.5. That's okay, because 10.5 is double, right? So that's what we saw before auto boxing. Okay? We'll accommodate to that automatically. Okay? So I can also do this, right? Right? And I can say add, and I can add an object of the wrapper class double and say 55.10. So that is, you know, you get a warning here because you don't need to put this new double. Okay, that's not necessary, but syntactically is correct. But this is unnecessary boxing. Okay, so I can easily do this, right? And that's okay, right? But let's leave it the other way because that's another way to do it. Okay? But intelligence tells you, IntelliJ tells you that that's unnecessary, although it's not incorrect. Okay, so now I can do this. Another method that this list has, and is remove 15.10, right? And that is auto boxing. Okay? It would just accept that automatically. Okay? Now, if I print now double list, right, I get this result here, 10.15. Right? Because remember, we added this guy and then we removed it. Okay, but we keep this guy here. Okay. Now let me create another variable here. Say double first equals double list get 0. Okay, and now I want to print first. So this makes sense here, right? This makes sense here because you're just using that object of that list, right? And with the get method, we are accessing the element number 0, which is the element number 1 of the list. And then, of course, we get 10.50. Okay, So this is another method that the interface list has. Okay, and that is, you know, the method get. Okay? And then inside here we can put the index number of the element. Okay, now if I do this, guess what's going to happen? We get an exception because we don't have any other method, any other element in that array. We only have one. That's why it's 0. So this has to be 0 to be able to get something. Okay, good. So we can have another list, but now it's going to be a list of integers. Okay, so that's a wrapper class integer, and we're going to call it numbers. Okay, new array. Okay. And then we do this. Okay, good. Now something that we can do is just add numbers to that, but this time I'm going to add a null. Okay, so guys, if I just use out numbers, what do you think we're going to get? Right? Makes sense if we get null, right? Because that's what I added. It's right here. Okay, so I'm getting a null right here. Okay, but I will create this guy after these two guys here. Okay. So now I get organized this. Okay, so that's what we added here. And why do you get null? Because the wrapper class, you know, accepts nulls. And by default, the initialized value of an integer with the wrapper class is null. Okay, remember it's a class, right? And if there's no objects, you know, it's null, right? Now, this, for example, what do you think we're gonna get here if we print that number? So what do you think we're gonna get?
No.
We're gonna get an exception, right? A null pointer exception, because we are pointing to a null value. So we get a null pointer exception, and also we get that because integers, the primitives, don't accept null. Okay, a primitive accepts a number, right? Like num equals 0 or number equals 5, but you would not say this. That's not possible. Okay, and that's what we're doing here. We're assigning a null value to an integer. So basically, what we're doing is this. That's what we're doing here, because this returns a null value. It's right here. So we are assigning this null value to this number, and that's why you get a null pointer exception. And of course, this will work if I do this. That will work. Okay, so now if I print this, I get a null here, and then if I do this, right, then I get the null. Okay, because this is a wrapper class and it accepts nulls. Integers don't. So this will not work. So it does not compile. Throws a null pointer exception. Okay. Good. Int cannot hold or be null. Okay. Good. Let's have another list, but this time it's a list of integers. Okay. Same as before. And now let's call nums. So new array, like we did before, right? And now we're gonna add numbers, add 1, which is index 0, and nums add 2, which is index 1. Okay. Now I can do remove 1, which is index 1, right? And then I can print nums. And of course, it's going to return 1. Okay. Right? So we remove this guy and then return 1. It makes sense. What if I do this? Nums, remove, new integer, 1. Still the same, right? But we have a problem here. Is this, it says that it's unnecessary. So I guess we get 2 here, right? Because what we're doing here, we're not removing the index value, we're removing the value 1. Okay, so you guys see the difference here. We're removing the index 1. If you use this here, an object of that, and you give it a value, remember that this, we saw this before, guys. Integer num equals new integer 1, right? We saw that before. If I print this out, num, I'm gonna get 1 here, right? I'm gonna get 1. So if I create a new object of the integer class, wrapper class, and I give it a value 1, it will delete the number 1, which is this one, and then return number 2. Okay. Right. So I will remove this guy. And then if I do that, what happens is that I return number 2 because it's just removing the value. Okay, so basically, guys, this is the same. Right? Just trying to remove the index 0 is the same as this. Right? Similar. But we're doing this guy here. So I'm gonna remove this guy here, just put it, and this will remove the element with value 2, with value 1. Right? And this one, this will remove element at position 1. There's a big difference between them. Okay? Big difference. So this returns 1. We're removing the element at position 1, which is 2, and then we're just keeping number 1. That's why this guy returns that. All right, so do you guys understand this?
Yes.
Yes? Yes?
Yes. Yes, yes.
Okay. So let's have another one. Let's have another class, and this class is going to be list array conversion. Okay? list array conversion. So PSVN. Okay. So now we have a list of strings, right? And we're going to name it names, names. Okay. And then we say new array like we always do. Right? So we have an array of names. And then we say names add Tony. Names add. Second one is Jimmy. Names add Anthony. Now I'm going to say object names array equals name to array, and then we're just converting this to an object array. Right? It was a list of names. Now we're converting to an array. That's why you say to array. Okay? Now if I do sys out names array, and let me first print sys out names. Right? And of course, this is not the way to print an array. If you just do this. Okay, where's, oh, sorry, I have to run it. So I'm gonna get, the list is gonna print fine, but the array is gonna print this object here. And we already know how to print an array. And if you can tell me, guys, can you enlighten me? Enlighten me? How to print an array?
Array.
Arrays dot
The string.
string, and then this guy here.
Mm-hmm.
Right? So now if I print this, I get exactly the same. So first, this was a list, and then we turn the list into an array object. We could have said this here, okay? Right? But we get a problem here. It says provided required string array, and we provided an object. Okay? So this is the way it is. Okay, that's the way it is when you change to an array. Okay, you change it to an array of objects. Of course, remember that the class string is a class, right? And whatever you have in that class is an object. So all of these are objects of that class, okay? Of the class string. There are strings there. Okay? So guys, if you do this, string my name, this my name is an object of this class, of the class string. Okay. So that's how we convert from an array, from a list to an array by just using to array method. Okay. Now I can do this and say, for example, I can say sys out names array dot length. Let's see what we get. And then we get 3 because we have here 1, 2, 3. And then that. Of course, when we do names array, we have all this method here, but you don't see add anywhere because names array used to be a list, because it's not anymore. Now it's an array. If I do here names, I get add and all the methods that a list has. But I changed it to an array, so it loses all those methods because it's an array. It's not a list anymore. You guys understand? Okay. So the way that we can make it a string is by doing this. String, right? And then we say string array. Before we use an object here, right? Because it returns an object. Now we're using string array, and now we say equals names to array, but now we have to do this, and we have to create an object of that, of the class string. Now, if I print string arrays, then see what we have here. Actually, I cannot do this way because remember it's a string, so I have to do it this way. Right. And then I get that as well. Tony, Jimmy, Anthony. So we changed from a list to an array of lists of strings. Okay, like here. But we have to use this thing here. If I put 1, I get exactly the same. If I put 2, I get exactly the same. If I put 3, I get exactly the same. But if I put 4, guess what we get? Null. Okay, so I can put 7 here and we get more nulls. Okay, so we're creating an array of strings here with a size, right? If I put 2, I get this. Why 2 doesn't change anything? Because I already have 3 here, right? And I just assign it to a string array, so it by default has 3, right? So I'm going to put 0 here, which is the same thing as well. Okay. So this creates a convert list to an array of objects. Okay. Or maybe of type object. And this will create an array of type string. Right? And then you can print it this way. I can create another string array, and I can say another string array. And say names to array, new string, and then we can say names dot size. So what are we doing here, guys? I'm sorry, this is not correct. It has to be this way. So what are we doing here, right, guys? Okay.
We're printing the array in a string format.
So basically, if I bring this, I get this. So basically what we're doing here is the same as this. Is the same as this. Right? Is it not the same? What is the size of the names already? Of the names list? What's the size? 1, 2, 3. So basically this can be substituted by 3. Right? Same thing. Right? Same as line 24. Right? Now we have an array of pets. Right? And that's going to be dog, cat, and parrot. Right? Now I can say, look how cool this is, okay? I can say list, string, pets list, and I can say arrays as list, and then we pass pets her. So what are we doing here? What are we doing here? Does it look like what?
Converting an array into a list.
So we're doing the opposite, right? Now if I have pets list, I have add, which didn't happen with pet array because it's an array. Now we change it to, you know, if I print pets list, that's what we get here. We get dog, cat, and parrot. So now we don't have to use this guy to print because this is not an array. This is a list. Okay? So we could have easily add one more element to that list, right? Okay? And say add and say maybe horse. Right? Now if I print that, I get, and in the out of bound, why? Why am I getting in this unsupported operation exception? Why? Do you have an idea? Well, I'll tell you, because this is a fixed list. Okay? This returns a fixed size list. We cannot add any more elements to this. That's the limitation of this as list. Okay? We're converting this array to a list, but we cannot add more elements. Or, let me see if I can remove. Let's say I wanted to remove element in index 1. Then if I do that, I still get that because it's a fixed size list. Okay? I cannot remove, I cannot add, I cannot do any change. Okay? So this won't compile. This won't compile. You can't add elements to this list. This won't compile because you cannot remove elements from the list. So as list returns, it returns a fixed size list. Okay. Good. Okay. Now I can say this, for example, I can say, give me pet list size. Remember that for array list is size, for list is size, for an array's length. Okay. Now if I did this, I get 3. No. And of course you can say, give me pets list, give me element, sorry, give me element in position 0. And then you get dog. Right. And you can print that array by saying for int I equals 0, and then int I less than pets list size, right? and then we say I plus plus, and give me this out, give me pets list index I. Okay, and I can say this, and of course, oh, sorry, get, sorry. So now I can say this, and then I'm gonna remove this LA here, and then we get the elements, you know, one next to the other. Beautiful. Okay, just by putting this I here, that will increment by 1, 0, 1, 2, and then I get all the elements. If I do here, give me element 3, or element 3, I just get an array index out of bounds. Okay, array index out of bounds, because it only has 0, 1, and 2. It has 3 elements, so this one could be 0. Right. Beautiful. So now I can say pets list, and then I can say maybe set 0, right? Bird. And we saw on Tuesday that this guy, what it does is just replaces. It doesn't insert or anything, it just replaces. Okay. So now if I just print this guy, then I can see that in index 0, we're not going to have, you know, dog anymore. We're going to have bird. All right. So I can just here seize out this guy, so I can have a new line, and I can see that this guy is bird instead of dog. Okay. So now, if I print arrays that to string, and then we say pets array, I print this guy, and I get the same. Beautiful and very interesting. Because remember, when we got this guy here, we linked them. Okay, so whatever change happens in pets list is going to be affected, it's going to be reflected in pets array. So let me add another guy. Let's say, well, actually, I cannot add. Don't forget that I can only replace. Okay, so I'm going to replace element 2. So I'm going to say pet list set. We cannot add. The only thing that we can do is replace. We cannot insert, we cannot do anything, just replace. Okay, so in position number 2, we're going to say shark. Okay. Now if I print this guy, I get shark, right? And if I print pets array, we get shark as well. Okay, so this link that was formed here, that allows for every change that happens in pets list to be reflected in pets array. Okay, so this the above links both pets array, pets array with, sorry, with pets list. So whatever change that occurs in pets list. Example, set new value will reflect on pets array. That's line 30 and 31. So this confirms what was said in lines 30, 31. Okay, perfect. Okay. Beautiful. Okay. So we try to remove, let's say that pets list, add, okay? Let's say that we want to add a new dog. Okay. And now we say this out, pets list. Unsupported operation, like we did before. And then if we try to remove, like we did here, it doesn't work. Right? So just confirm. Okay. Perfect. Let's have another list. This time is a list of string. And let's go to list. And then, like we always do, but this time we're going to do array as list. And then we're going to add the values here. Okay. So we're going to say 2. That's another way to do it. And then 3. Okay. Right? Now we print list. Right? We get that 1, 2, 3. And if we do list add 4, and then we print list again, then we get unsupported operation. Same thing. Okay. So this is, you know, an anonymous array here. We're just adding the values here, or we could just simply, you know, like, you know, calling a variable here, and then put it inside the list. Here we're just hard coding the values. So this is wrong. That's one compile. Any questions, guys? No? Okay, so we continue. We're gonna create another class, and this time we're gonna call it sorting a list. Okay, we sorted arrays before, we're gonna sort a list now. Yes. Okay. Remember how to sort array? We use arrays that sort, remember? Okay, this is a list now. Okay, so a list doesn't have that method. So if I say list string, a list of string, and now we say num list, right, equals new array, right? We cannot say nums list that sort. That's you have to use another thing, a comparator, things like that. That's not the way you do that. Okay. Now we're going to add, you know, we're going to add elements here. We're going to say 500. Right? Remember, it's a list of arrays. Okay. Strings. I'm sorry. Let me add 5 numbers here. Okay. Second one is 10. Third one is 9. The other one is 50. And the other one is 40. So we can print the nums list, and this is what we get. Okay, so that's what we get when we do that.
You need to run the,
We didn't get anything. I have to.
yeah. Thank you.
Okay. So we get all those guys, but as you can see, they're not sorted. Okay. Okay, so to be able to sort this, we have to use an interface. Okay, and that interface is called collections. Okay? Collections. Okay? So we have to import it. It imports it automatically when you click on it. And then we can say sort. And then inside that, you put num list. Okay. Now, once it's done, then you can print it. Okay. So now if I just do this, I get it.
You didn't sort.
Yeah, because this is, remember, this is, these are arrays of, these are strings.
Strings.
Yeah, you know, it's a little more unpredictable with strings. If I put numbers, let's say that I want to do a list of.
You know what is looking at the first
Letter?
item, the first item on each one of the strings. If you look, it's 1, 4, 5, 5, 9, and it's negating the next number.
Yeah, but kind of inefficient because 500 is greater than 9.
Yeah, that's, yeah.
So I'm gonna do this nums equals new array. Okay, let's see of numbers. Okay, so I'm gonna have these guys here. Maybe this one first. And now we're gonna do 500, right? And then like this. Right? Okay, and now I'm gonna have the same numbers. Okay, so I'm gonna do the same thing. In this case, it's gonna be nums. Okay, let's see what happens now. There you go. So with numbers is different. With arrays, it's a little more unpredictable. Okay, because you can think of probably the letter 4, 5, but 4 and 5, they have the same F, same initial, and O is after I. So 50 should be before 40. Okay, if it is by the letter. But otherwise, as well, in addition to that, 10, which is T, should be the last. So it's not even considering that as a string of the first letter.
I guess if you
Yeah,
turn,
I think that what it is doing.
Turn it into, if you turn it into a string with characters, you will do it correctly, right?
I think that it's more. I'm more inclined to believe what you said, Maria, like the first number, you see, and then obvious, just ignoring the number that comes after.
Can you do the same thing with words, for example?
Words, okay. Let me do that. Yeah.
Yeah, string. Mhm.
This makes more sense than numbers. All right. Makes more sense than numbers. All right. So I'm gonna do exactly the same thing that we did before, as we did before, but this time we're gonna do it here, and this time it's gonna be words. Right. Yeah, this makes more sense. That sounds like it's going to do it alphabetically. Okay, and there you go. It's alphabetical. So, it's kind of, kind of, you know, it's kind of, kind of unpredictable with this guy. I can make it easily. I can just say 4, right? I can say 4, integer, num. In nums, right? I can say int n equals integer, that parse int and then num, right? Require a string. Right, because it's this one. It's this one, not the other one. So string, right? And then in num list, right? And now I can say nums list. So now I can say num. I parse it into an integer, and then I can add it to a new string, new integer, right? Let's say converted array of int, right? Equals new int, and then the size is 5. Right? I have 5 numbers here, 5. So I can say, I should have used, well, don't worry. So I can say convert array of int, and then I would say counter, which I don't have declared yet, equals n. Okay? So now I'm going to create a counter here and say int counter equals 0. And then right now I'm going to say counter plus plus. Okay? Right? So now when I have this guy, it's not used. Okay? When I have this guy, I can say this. Okay? And then I say converted. All right. Of course, erase that to string. Or actually, that was a list, right? It's a list. So I cannot do that. What I'm going to do is convert the array. Okay. Okay, this is a list. So I have to say list of integers, right? And there was a new array list. Okay. And now instead of doing this, what I'm doing is just adding add n. Okay. Makes more sense now. This counter is going to go. Right. I don't need this counter. Now I can do this and convert the array. And then this is what? Okay, of course, I have to remove this. Convert the array. And then that should be, you know, sorted. Okay. There you go. Just like here. Okay. So what I did here was just bring this array of integers, because even though they have numbers inside, they're integers. I'm going to declare a new array, a new list that is empty. There's nothing here. So I said for every string in the string, in this list of strings, nums list, right here, let's just parse every string to an integer, right? So we're converting that string to an integer. And let's add that integer to the new array, to the new list, I'm sorry. But I made it global. I made it outside this block. Because if I put this guy inside the block, it would not be accessed from outside like here. Okay? So I made it a global variable, right? That can be accessed down when you go down. Okay? So I just added that in, that number, and then I can access the number here. Before you know, sorting it, and after sorting. Okay. So I can simply say here, unsorted list, and then we can say sorted list. Okay. Unsorted list, sorted list. Okay. See, guys, so you have to use the collections interface to sort a list. For arrays, you use the class arrays and then sort it. Okay. For collection, you have to use a collection because this is a collection. List is a type of collection, like it is a set, you know, a queue, things like that. A list is a collection. Okay. You have a collection of elements. That's why I call collection. We have another list of integers, right? And now we're going to call it numbers. And we say new array. Well, actually, no, we say arrays as list. And then we're going to say 5, 4, 8, 10, 11, 7, and 3. Okay. Now we're going to say is it print just the numbers. Okay. And we get all the numbers here. 5, 4, 7, 8. As you can see, they're not sorted. It's just the way they were added. Okay, I can say collections and sort numbers, and then I just can print numbers again. Okay, and you get this sort. Right? So even with this, you know, conversion here from an array to a list, right? It can happen. Guys, do you think I can do this? Do you think I can do this? Do I have a list already? I don't think so, right? No. Can I do this?
Yeah.
What do you think? If I change this to string, what's going to happen?
So I'm going to let you.
Because you have several types, right?
You have several types.
You have,
For an object, it should allow you to.
yeah, because everything is an object.
Uh-huh.
So if I now print list, then we get this beautiful thing here. Okay, that's the power of lists. Okay, but don't forget that this is a fixed thing. So this will give me a problem here. Okay, that we saw before. So this is not allowed. Any operation that affects the list, like adding or removing, right? Changing the size of the array will not be allowed. You can set, but you cannot add or remove. Okay, so now I can say, for example, here, I can say list, set, and then I want to change my name to Lunes Quintana. Okay. So now I can print it again. And that is possible. Okay. That is possible because you're not adding or removing, just replacing. Okay. Good. So let's just have another one. Any questions, guys? Any questions? No?
Oh.
So you can see this part of it, arrays is very long. Huh? Arrays is super important, array list, arrays. So searching a list. Remember how to search an array? Remember the binary search, right? Here we have a list of numbers, but I'm going to use the same as I used before, this one here. Right. Exactly the same list. So I don't want to type again the same thing. So I'm going to use num list. Okay. So that we already know what we're going to have here. We're not going to have what we want because I have to run it from here. Then we get the list that we have here, all the numbers. Okay. Now remember when we search an array, we have to use arrays.binary search. Remember? Now, as we're working with lists, we have to use collection. Okay, so binary, and then we say nums, right? And then we say 10, right? So something very important. You see this message here, it says results of collections binary is ignored. Does it sound familiar to you? What was the type that ignore things? Remember when we did this, for example, this like names like string, remember? That returns something and it was immutable, remember? Remember strings? The word immutable? And we had to just to store in a different variable to be able to have a result. So this is ignore. We have to do this, right? We have to put it in a variable. Okay, and now it's not ignored. So if we say this is our index, we're gonna see that number 10, or whatever string you say, number 10 is gonna give us a value here. -1. Okay. Now, we get -1 here. Right. It means that, it means that something is missing. What is it, guys? When do we get number minus? Guys, are you studying what we see in class? Guys, you here?
Dog answer you.
Remember, we get -1 when it doesn't find it. When we have,
Yes, exactly.
remember that we don't have, when we don't have a sorted list or array, it gives you an unpredictable number. The result is unpredictable. I think I put it on Slack after the class.
When the element is not found, it's going to send minus any number.
So am I going too fast today, Maria?
Yes, you are. You're going 100 miles an hour.
I'm just going the same speed that before.
No, you're not.
I'm not?
Nope.
Okay. And what did you guys tell me?
I did.
Yeah, but through Slack. I checked Slack because I have to check something that I posted on Tuesday.
Because you're in the middle of teaching something.
It doesn't matter. Professor, you're going too fast. Doesn't matter. All right. So here, searching arrays, element found, element, index of element that was found. Element not found, negative value showing one smaller than the negative of index. Where the match needs to be inserted to preserve sorted order. Unsorted array, result not predictable, undefined result. And that's what's happening here. We don't have a sorted array, right? That's why this is happening. Okay, so now what we have to do is to be able to sort the array.
Collections.
Okay. And then you're gonna be able to find it. So before we print the list, let's sort it. Okay.
Mm-hmm.
So maybe here, collections, okay. And it's sort non-list. Right, if we do this now, we get 0. Okay. Now we're still not getting something here that makes sense. Or actually, we are.
No, it is correct.
We are able that. Yeah. I was thinking, I was thinking about this, but it's sorted. So 10 is number 1 in this weird string array. 10 becomes 1. If we print this guy now,
Index
10 is number 1. It's not is position number 1. Index 0. Okay. But for the binary search method to work and to give you the expected result, you have to sort either the array or the array list. Okay, you have to sort them using the respective, interface or class, whatever you are trying to sort. Okay. So we get 2 different results if we, sort it, and if we get, let me put this here before sorting it, and then I'm gonna put this here. I'm gonna say index 1 and then index 1. Okay, so now if I just print this, we get 2 different results. We get -1 when it's not sorted, and we get 0 when it's sorted. All right. Hope you guys are understanding what I'm doing here. All right. So now I can have another list of integers, and then I'm going to call it numbers. Right? We're going to change that to a list, and then we're going to say 4, 5, 4, 10, 11, 7, and 3. Okay? And now we're going to print the numbers list. Okay? And then we get, you know, pretty predictable. Right? Now we're going to search for a particular, I'm going to choose index again, like reassignment evaluate. I'm going to just do collections because I'm going to use the binary search method, and I'm going to say numbers 7. Okay. Now I'm going to go ahead and print index. 7 is here, right? But remember that this is not sorted. Okay, so we're going to get something here. Very unpredictable. It's -3. Okay. Okay. So it's basically telling you, that this guy here, number 7, should be in the index 3. That's what it's telling you. That's where you should insert it. So because if you sort it, it's going to be 3, that's 0, that's 0, 4, that's 1, 5, that's 2, and 7 would be 3. Okay? When the item is there, it's going to give you, you know, a minus number, but it's going to give you the index where that number should be inserted to preserve the order of the list. That's what it's doing here. Okay? Now, if we do collections, sort that particular numbers list, and then we print the list again, right? Numbers. Then we get another guy, right, that is sorted, and then we can do this again and look for number 7, right? And then we're gonna get 3. You see? It gives me the index where that number is. Same here. It gives me a negative number, and it gives me where that should be. If you read this, negative value showing 1 smaller than the negative of index, where a match needs to be inserted to preserve sorting order. Okay? So that's this minus right here. Okay, guys, you understanding? Am I going slower now, Maria?
Yes.
Yes.
You slow down a bit.
Okay, guys, it's 6:40. Let's take a break. If you don't have any questions, ask now, or we can go and break for 10 minutes. Let's be back here at 6:50. Okay, guys, let's continue. Okay, so we finished that the search. Let's do some uh, iterating a list. Okay. So let's have here this guy here, and let's put here iterating a list. Number one, because we're gonna have to. So I'm gonna run this guy. Gonna run it. No, I cannot run it because we still don't have this guy. Then we can run it. I'm gonna run it here. Just make sure that first time we run it, we're gonna have it there. Okay. All right, so let's see this guy. Okay. So we have a list of numbers, and I will try to go as slow as possible. Numbers, and then we say new array. Say that. Okay, good. Now let's add, you know, one number here. Say number 2. Let's add another number. Add number 4, and let's add another numbers. Number 6. Okay. Give me 1 moment, guys. Just 1 moment. Sorry about that, guys. So I have this number here, and then we can say, just this is a way to just to iterate. We say for int I equals 0, and then I is less than the size of the list, right? Size of the list, and then we just increment I. Okay, so now we can say system out. We can say element at index, and then we can say I, right? Index I is, and then we can say numbers that get I. Okay, so that's a pretty simple print of this of the elements of the array, of the list. I'm sorry. So we have this, and then we say element and index 0 is 2, element at index 1 is 4, and element at index 2 is 6. Okay, so that's one way. Now we can do another way, and this is a for loop. We're gonna use an enhanced for loop, which is the other one that we guys have seen so far. Okay, integer, right? And then we say number in numbers. Okay, so for every number in numbers, just give me the number. Okay, we say number. We do this, and then we say number. Okay, so we're printing that. That is another way. This is a for loop, and this is an enhanced for loop. All right. The only disadvantage with this is just in case you want to put like a counter or something, it doesn't have this I here, right? So you would have to, whenever I put I here, I print I, so I can have that number incremented, right? So I do this, and then I get this number incremented, okay? 0, 1, 2, okay? We don't have that with this guy, okay? So we will have to do some work around here and probably just create a counter here, probably somewhere here. Say int counter, right? And then we start from 0. and probably we can say here number at index, right? And then we say counter, right? Something like this, and then we have to just increment the counter. Okay, so that will be probably one of something similar that we can do, and we get exactly the same thing, but just different text. Okay, but it's almost the same. So we have to use a counter. That's the disadvantage of this guy. We don't have this I that is, incrementing automatically. We have to use a counter like another guy, but we can. But still, it's good. Okay. Now, so here we're using the for loop. Here we're using some people call it the enhanced for loop. All the people call it for each. Okay, and for each. Okay. Right. Now let's see the iterator. Okay, and we're basically doing the same thing, just another way to do it. Okay, so we can say for, and of course using a for loop here, for Iterator, which is a class, right? Iterator is an interface, not a class. Iterator, and then this is an integer because we have numbers, right? It's not iterator, this is iterator. Okay. Right? Then we can say, we call it iterator if you want to, anything you want. Okay? And then we can say numbers, that's the list, right? Numbers, iterator, right? And then we can say iterator has next, that's to jump to the next one, right? And then we put it here, guy here, and then we say, say this here, right? And then we can say integer number equals iterator that next to jump to the next one. Okay, and then we can say sysout number. Okay, so this is another way to do it. Okay, and then we get the numbers here. Okay, so this is the iterator. So we use this iterator with an integer because if it is a string, it's a string, right? This is an integer. We give it a name, and then we say equals that numbers. The numbers, the list, right? The list here, and then that we get this particular method here that the list has, right? And then we are finding the next element in the iterator. We just store that next in number, right? That's going to be the number in the next iteration, and then we put the number here and we print it. So basically we're just iterating similar to this, right? But it's a different way. And of course, this number is going to be a type iterator. That's why you can use this guy here.
Can you rename that to make it look like it's a variable? That one where you have the cursor over. Just change it to something. Iterator num iterator, something like that.
It's just the iterator is just the standard way to
Yeah,
make
that's in it. Yeah, but
it's just a standard name, just for you to know that's in iterator. It's just a variable with name iterator of type iterator. So that's another way to do it, guys. So maybe guys, you can do, maybe if you want to know a little bit more about the iterators, see more examples, you can use this guy here. I don't know if you ever used W3 School. Have you ever used it? Never?
Yes.
You can see more.
Mm-hmm.
Okay. Very useful.
Oh yeah, definitely.
I have a lot of languages there.
Can you go to the top of this package all the way to the top? There you go. So it's added, import the iterator. Okay.
Right. It imports the interface. Right.
Mm-hmm.
As soon as you put it here, that's, guys, this is because IntelliJ is super sophisticated. If you use Eclipse, for example, you would have to, it would just signal, like give you a line below it, and then you have to right click and then import it. Okay? But this guy is super smart, IntelliJ, right? Which doesn't help much when it comes to the exam. Okay, because sometimes you have some conflicts here with the imports. It just removes it, puts it back. It kind of confusing sometimes. So let me get another one. So maybe you can do, probably in the meantime, you can probably here say Iterator, remove. Let's see what happens. So it doesn't give you an error, okay, because it's not a fixed size thing like the one before. Right? Okay, so that's all for the iterator. All right, let us do the second part of this. Put here number 2. So I'm going to create a class. Number 2. Run it. So click this guy here. ESVN. Run it. And it's ready. Right. So let's do number 2. So what we're going to do is now see, which one is faster. Okay. With all the iterators that we know, which one is faster. All right. So we're going to have a list here. And as you can see, it will automatically import that guy. You see, it imported it already. And we're going to say list equals arrays as list, right? And then we're going to have a method call. Okay, we're going to say create array. Okay. Okay, so that's a method call. Okay, in the method call, we're going to say here, down here, and we're going to say private static string. Right. We're returning a string, right? Create array, and then we're not passing anything. We're just calling the method, and as you can see, it already disappeared the error that we had here. Okay. So now we're going to say string, right? String array equals new string, and then the size is going to be 10,000. Right. Right. Now we say for int I equals 0, I less than string array length, we say I plus plus. And we're going to say string array of I equals, because this is a string, don't forget that, array plus I, concatenation, okay? Concatenation. It's going to be array 0, array 1, array 2, array 3, concatenation. And then we're going to do what? Because, you know, we have a return type here, an array. So we have to return string array. Okay? Okay? So whenever there's this method call, it's going to be a value that's going to be returned by this method here. Okay? So now that we have that sorted, okay, we're going to say long, right, start time equals system dot current times in milliseconds. Right? And now we're going to say here that this is the for loop. Okay? Now we're going to say for int I equals 0, and then I is less than lit size I equals, and then we do this. We're going to have a temporary variable string, and we're going to say list get I. Okay. Perfect. Just to put something inside here for that to, you know, we're not going to use this temporary variable, but just for that for loop to do something. All right, you try to looping as many times as it says here, right? And then we're gonna, you know, actually we're gonna be reassigning. We're not creating another array. It's just reassignment. Okay. Now we're gonna have long total time, right? Equals system dot time minus start time. Okay, that's going to be the start time, how long it takes from here to here for that particular for loop to execute all of these arrays, of that list of, you know, this array here. Now we can do now and say this out. We can say for loop, right? Total time equals plus total time plus ms, milliseconds. Okay? That's what the for loop will take to execute. Okay? So let's see it. See what we get here. 2 milliseconds. is what it takes. Your computer may be different than mine, maybe faster, slower, it depends. So it took 2 milliseconds to run this guy. Okay? So if I just sys out temp, right, we get this. So guys, that took, 2 milliseconds before. You see how long it took? That's a long thing, right? So it takes 75 milliseconds because now it's not only reassigning, it's also printing.
Okay.
That's why it takes 75 milliseconds. But if I remove this guy here, or just comment it out, it takes 1 millisecond now. It depends on how fast the computer is. Remember, there are processes behind in the background. Several processes probably ended, before I did this, and now it takes much less than before. If I do it again, 1 millisecond. If I do it again, 1 millisecond. Okay? Maybe if I wait a little bit longer, it would take 2 milliseconds or 2 or 1.5. It depends. Right? So we see how fast the for loop is. Okay? Now let's take a look now at the for each, which is the enhanced loop that we did before. Okay? So now we're gonna do long start time equals, or actually I already have a start time, so I'm gonna just reassign. Okay. Right? So I'm going to just reassign, it doesn't matter. Right? I'm gonna say system dot current, that's the current time, right? When it starts. Yeah. Okay, and now we're gonna have the for each. Right. So we say for string temp, could be any name, okay? In list, and then we say, nothing. We don't need to say anything. Okay? We say do this and this. Okay. Now we say total time equals system dot minus start time. Right. And now we can say this out for each total time equals total time ms. Let's see. Let's see what we get. Okay, take the same time. Let me put something here like probably reassignment. So string temp 1 equals 10. Okay. You see? As you can see, we're doing this exactly the same thing here. You see? And now the for loop is faster than the for each. Okay? So do it again. Now it is the same. Okay? It all depends. Do it again. Do it again. Maybe a little bit later. Do it again. Right? So now let's see the iterator. Okay? So I'm going to see the iterator here now. Right? So we're going to see start time equals system that milliseconds, current time milliseconds. And then we're going to say for iterator like we did before, right? And that's going to be string, right? Before it was numbers. Iterator is pretty standard to name it iterators. Okay? So list that iterator, and then we have iterator has next. It's similar to I++, okay? Similar. Now we do this, we say string temp equals iterator dot next. Okay, we're just assigning the next element of the array. In the case of 0, go 0, then 1, like that. Okay. So now I can say total time equals system dot millisecond minus start time. So it says out iterator total time equals total time milliseconds. Okay. So now we can take a look at this. Let's see. It's even faster than the other two. But that's one here. Now for each is faster. So it depends on your computers, guys. Now all of them are 1, 1, 1. All right. And then 0 now. All right. So this is telling me that you guys have options, right? You have options. Okay. So let's do another one. Okay. Let's do another one. In this case, we're going to do the list iterator. Okay, maybe guys, you wonder what's the difference between iterator and list iterator. Well, the only difference is that this guy can only traverse the list moving forward. So forward. The good thing about list iterator is that you can traverse the list or the collection back and forth, like forward and backward. Okay, that's a good thing. That's why this guy has a previous. This one has next. The other one, this one has previous. So you can go back and forth, you know, and it is more, you know, encompassing than iterator. That's mainly the main difference between them. So the iterator can traverse the elements in the collection only in forward direction, but list iterator can traverse the elements in a collection in both the forward as well as the backwards direction. Okay. So let's have the iterator, list iterator now. Okay. So I'm going to have the start time, like we always do. Right. And there was a system. 30 seconds. And now I'm going to have 4. And of course, if the other one was iterator, this one is list iterator, right? And then, of course, it's going to be a string. It's a list of strings. And then we're going to call it list iterator. It's just standard, you know, standard. Okay. And we're going to say list iterator, right? List iterator, just like this one, but in this case, iterator. Now it's list iterator. Okay. And now I'm going to say list iterator has next. Okay. So now we can say string temp equals list iterator, then next. Okay. So you can see basically it's the same syntax. It's just the word iterator that changes list iterator. And of course, list iterator and list iterator, but based on the number, the name here. Okay. Now I'm going to say total time is equals system dot that's minus start time. So we can say sys out list iterator total time equals total time and then milliseconds. Let's see now. You see, they're pretty fast, all of them. Right? They're pretty fast. Let's see here the list iterator. I wanted to leave it for the end. Okay, and I want to say here list iterator. Right. And I want to say here numbers. Okay. And by the way, this is another way to add a collection, right? Add all and then arrays as list. So similar to this, guys. Similar to, we don't have this here. Let's see here. Similar to this, you see? But now we're using the collection, where is it? The numbers add all here, okay? So now here we can say 1, 2, 3, 4, 5, and 6. Okay. Okay. So this is basically like this, guys. List, right? Integer, right? Equals num, and then arrays as list, and then 1, 2, 3, 4, 5, 6. Okay. Same thing. Right? And then you can, but this is when you have the numbers already, you know, declared before. That's why you do this. Okay. So very similar. So we have an array here, right? That is, you know, changed into a list, right? This is changing it to a list. It returns a fixed size list, right? Now we want to iterate on this, right? So we want to say for list iterator, right? And then of course it's integers because I'm adding integers in here, right? And then I'm gonna call it list iterator, right? Now I'm gonna say numbers dot list iterator. I'm gonna pass number 2, right? Now I'm gonna say list iterator list iterator list iterator has previous. Okay. And then come on here, I open this, and as a system out, I can say list iterator previous instead of next. Okay. So now if I just print this, oh, sorry, I have to go back to 1 and print this. Okay. We get number 2 here, right? We get number 2 because number 2 is the previous element before 3. We're passing index 2 right here, 0, 1, 2, that's number 3. And we're going to say, give me the previous element before 3, and that is 2. Okay? So we can say here, element before is, okay. So now I get that. It says element before 6 is 4, element before 6 is 2, of course, because remember, I'm doing this inside the loop, okay? And it's kind of, messing this up, okay? We're just passing number 2, right? And that's what we can get here. All right? See, guys, these guys can traverse the array moving forward and backwards, okay? That's the good thing about list iterator. With iterator, it's only next, and with list iterators, you can go previous as well, okay? That's the thing about that. Now we can say system out numbers, and then you can print that, and you get that numbers here. So see? So it's a 1, 2, 3, 4, 5. It gives you the previous number, and then 4, 6, 1, 2, 3, 4, 5, 6. Okay, kind of, it's kind of weird. See that it prints all these guys here. It gets 2, and then 4, and then 6, right? And then it does 1, 2, 3, 4, 5, 6. Okay, so it gets the previous, right? Starting at index 2, right? And then it gets 2, it jumps to 4, it jumps to 6, and then print 1, 2, 3, 4, 5, 6. Okay?
That does not make sense to me.
Yeah. Kind of weird, right?
Very.
Yeah. Yeah, it traverses the array, the list back and forth the way you want. Right? If I were you, I would choose this one. It's more predictable. And so this one or this one. Okay. So we could do that. Let's see what happens now. See? You get the same thing. Next here. And then next. Okay. And then, see, we get 1, 2, 3, 4, 5. You still get this guy. Okay. I put it back to 2. That was. And then previous year. Okay. So there's a little program here with the list iterator that you can say, for example, array. I'm going to use a list instead of array list. So a list. Right. And then I'm going to say a list of integer. I'm going to say iterate nums. Okay. I'm going to say new array. Yes. I'm going to add numbers. 1. And then I'm going to say 2, 3, and 4. 1, 2, 3, 4. Right. So now I'm going to use the iterator here. And I'm going to say iterator, right? ITR equals list, where in this case is iter, dot iterator. Now I can say system out iterator and I can say system out forward traversal. And I can say while ITR has next. Right? I can say sysout ITR next. Right? And then plus space. Okay? Let me leave a space here in the middle. And then if I print this, what line is this? Okay, I'm getting an issue here. Such element exception. What line is that? Array list previous. Previous. Oh. So now we have iteration 1, 2, 3, 4. That's forward traversal, okay? So now let's see an example of, forward traversal with the list iterator, okay? So let's say iterator here, forward traversal. Okay? So we're just traversing forward. Okay? And then now we're going to see list iterator forward traversal. Okay? So we now do this. We say list iterator, and then we're going to see integer. Okay? And then we're going to name it I. Okay? So we're going to say iterate nums that list iterator. Okay? System out, I can say list iterator. Right? And then we can say sysout forward traversal. Okay. Right? So while I dot has next, not previous, next. Right? Require a Boolean. Oh, has next. Okay. Then we're going to say okay. We're going to say system out I does next, and then we say plus this guy. Okay, so we print this now, and then we get forward traversal with this iterator. All right, so forward traversal. Okay, now let's see the difference, because this is the only one that has, you know, backward iterator. Okay, so we're gonna say now system out. We said backward iterator. Oh, traversal. I'm sorry, traversal. Right, and then we say while I has previous. Then we say sys out I previous plus this. Okay, and now we say sys out. No, not here. Outside. Okay, so now we can see that here we get 4, 3, 2, 1. Okay, so this guy here doesn't have, you know, like saying I, you know, that's the least iterator. This guy here, like ITR, doesn't have a previous, so you cannot traverse, you know, back. So guys, that's one way that you can print the numbers backwards, the array backwards, by just using the list iterator and the has previews, just to make sure that, you know, it has a preview. Okay. If the array has only one element, it doesn't have a previous element, so this will return false. It returns true, and then if it returns true, you can print this, right? Because it has a previous one. Okay. Now, if I have, like, probably, let me see, if I have an array of numbers that has only have one element, let's say that we have probably list of integers, integer, and then we say 1 equals new array list, and then we say probably say 1 add 1, right? And then we say list iterator, right? Integer equals 1 list iterator equals 1 dot list iterator. Now if I say 4 list iterator, no. So it was y list iterator has previous. Right? Sys out list iterator previous. See what happens. Nothing is printed, right? Okay. This is not printed, okay? Because there's no previous thing, okay? Now, if I do this and I add another one, let's say 2, so we can say here, probably, we don't get anything either. So we're printing here. So 1 here, 1, and 1 here.
Professor, I think that the issue is the point is in the first element and it has no previous. I think.
Yeah, but this one didn't have a previous either. And it's working here.
Like you first move forward and then move backward.
Okay, let me see that. It's pretty weird. It's pretty strange. But you have to have forward and then backwards. Makes sense. Makes sense. I don't use this guy too much. Okay. Thank you. Appreciate it. Okay. Well, you guys know already how this works. Okay. So you can do forward traversal and backward traversal, right? With the iterator. the list iterator, and the other one is that. Okay, guys, that's all I have for today. Still 7:46. So, do you have any questions?
This is plenty. This requires some serious thing again.
This is serious.
Yes. I've been trying to follow through, but I need to study this more.
Yeah, it's you know, Java is a very, very, very tricky language. It's very tricky. It's very
There's too many
very-
things.
too many details. It's very deceptive. It will, I think, is demon possessed, but at the same time, it's a very powerful language. It's it's the only language that is compatible with any platform. You know, it's write once, run many. Okay, so it's why they call a warm a warm language. Okay? Write once, run many. Okay? You run it one time, and then you can run it in any platform. Okay? So, guys, I'm going to post a little test for module 5. Okay. I'll post it on Slack. And module 5 is the one that we just finished. Okay. It's only 10 questions. It's not. Guys, are you practicing with Quizlabs?
I don't have access to WizLab.
Well, I
I don't
confirm.
have access.
I confirm with
I
Mulet.
never received an email or anything that we have.
Yeah, Eduardo Mulet confirmed to me that he got it. So probably, yeah, guys, you have to check your spam folder or your promotion if you have an email, Gmail account. And I believe you guys have it. So I
Let me
posted,
check it.
yeah, I posted the test on Slack. Okay, so you guys can access it and take it now.
I don't have anything.
No?
Nope, not at all. Not in my spam. I searched for WizLab.
Can you write an email to the team telling him that you never got it? This is the one that sets the access.